Hello. I think you can hear me, right? So today I will be talking about the container security. The containers are actually the new eras of executing applications, but there are some complications. And actually, it's not a complication, but it's a new way of executing applications. So it's different from the way that we are used to execute binaries or execute applications or server, whatever. So based on that difference, we need to actually change the way how we secure it. So we need to know a little bit about it. So after that, we need to know how we secure it. So today I will be showing and describing some different things that we can do with that. Anyway, so the container security. First of all, so what is container? What is a container? So we need to know what we secure, right? So at least we need to a little bit know about the containers. So probably most of you know, but I will be giving some very simple explanations of the containers. So the next, do we really need to secure the containers? And how to be secure it? And how to find the vulnerabilities on the containers itself. So the containers is actually, I will not go with the official explanation in the Docker.com, but actually is a lightweight standalone executable package of applications. So basically, you confine some applications in a simple file, so you can run instance from this. Basic operating systems, when you go, I am a Unix guy, but when you execute a top command, you will see lots of executables. And when you go to the Windows, you run the task, you want to see the task that is being run right now, you will see a lot of executables. But the containers are different. So you create an image, and you put only one, or anyway, a few executables. So you basically create an environment to run that application, whatever it is. So you are basically creating microservices based on the security. So the first one is the official explanation that can be found in that link, but the second one is what I found in, when I try to understand that concept. So the container is actually, it is what it is. Let's say that for the virtualization, we virtualize the operating systems. That is what virtualization is for. But when we say about the containerization, we virtualize the applications. We confine the applications in simple zip files or compressed files, so it can be run in a confined environment. Basically, it is more secure. But the way right now we execute it, can create some complications based on that. Because in containers, we always do root users, the privileged user to run the applications that we think that nothing going to happen. Basically, when the web developments emerged with the new web technologies, we thought that, hey, my database is secure. No one will see it. But after the evolution of the web application security standards like XSS, SQL injection, things like that, we understood that our application is not secure. It will be a process that people understand the way to secure the containers. So we need to prepare ourselves. So if you want to know more about the container, what is it, how to use it, basically the Docker the Docker is the leading, actually there are more container technologies, but the Docker is the leading containerization technology. So you can read this book, an O'Reilly book, for the containers. So, actually, when you say Docker or containers, it's a resource isolations and utilize the features of Linux kernel and the C groups, that is, confining some executables and namespace, and especially the union layer file system. So basically, whenever you execute a command, you create a layer and layer and layer. So it is different from the way that we understand the operating systems. So when we compare the virtualization with the containers, it's actually in the virtualization we virtualize the operating system, on the top of the hypervisor. But with the container, we don't care about the operating system because we virtualize the software. In the VMware or other virtualization technologies, you multiply the virtualized operating systems, but most of them use the same executables, like the Windows kernel, like the drivers, like the services, things like that. Most of them are actually using the same amount of memory. So the container is something else that we actually do not virtualize the operating system files, but we actually virtualize the applications. So it will use less RAM, memory, and it will be more secure because the container cannot get off and the operating system will not be hacked by that. At least right now we think about it, but even with the virtualization, we think that the hypervisor is not reachable, but there have been some vulnerabilities to actually get the information from the hypervisor itself, and also the worst, then you can get information from other virtual machines with the new vulnerabilities like Meltdown, Spectre, or other vulnerabilities. So same will happen for the containers sooner or later. So if we combine the containers with virtualization, again, this image is taken from the Docker.com on the page that what is Docker, or the leadership containers technology. So we can use the hypervisor technology and use also, we can create virtual machines and we can create Docker images inside virtual machines. So it's easier to implement, easier to manage, things like that. And in today's environment, that is how we use the Docker actually. We don't, some big organization can use directly bare metal operating system, but it is easier to use the containers in a virtual environment for its sake. Anyway, so container penetration in technology. So the containerization is everywhere. So in years by later, you will see that most of the things will run in the containers, not like in standard operating system. So we need to know it. So it's a new era for application development. Application developers they love it. So the system administrator or so-called DevOps administrator will love. They need to use it, and we cannot live without it. So we need to first harden the components, just like standard operating systems. At least make that system or whatever the operating system more difficult to hack, even if there's vulnerabilities. So the hardening thing is very important. So there are some standards I will be talking later. So, and even we harden the operating system, or binary itself that is executed or the operating itself, it can contain some vulnerabilities. So we need to be aware what kind of vulnerabilities in the containers, the instance. So the containers really need security. So you may think that it runs on a small image and very confined image. That one executable, let's say that if you run an Nginx server, with some additional binaries to start the service, the Nginx server or whatever you are interested in, it's running in a small environment. But again, it reaches out somewhere, it connects to your backend database, things like that. So if it's been hacked, probably they can, with the previous slides. So the hacker will, the lateral movement was mentioned to you. So the hacker will enter to your application, then will try to penetrate to other instances in your environment with the lateral movement in the way that the hackers move. Anyway, so and there will always be vulnerabilities for the containers, always, because as we have seen the technology, how it moves, 100% sure that near soon that someone will find actually the vulnerability for the image or vulnerability for the container, Docker itself. So we need to manage those environments. We need to know what kinds of patches should be applied. We need to know what is in our environments. So in the containers, actually, you will be the responsible, not the operating system vendor, because you will be not using the operating system's when there's packages like RPM file in container, you need to put your own binaries, like compiling from source. So I don't know if you have managed an environment like that. There was an operating system, Linux operating system called Gentoo. So you are basically compiling everything from scratch. It's something like that. So you need to, you cannot trust on the operating system vendor, because operating system vendor, even the container one, will provide the basic ones. So you are putting your own binaries. You are compiling the Nginx or the whatever web server it is. I mean, you get it, but it's being compiled. Or you compile your own binaries. So you need to find a way to secure them, because you're responsible. So it's a great thing, but it will bring you some responsibilities for that. So you need to harden and audit and patch your containers, and also the host platforms for the misconfigurations and vulnerabilities. So how we do that? So what kind of things we can apply on the containers? So a simple roadmap that I've thought about how to help to the people that secure the containers. That first, you need to harden your hosts that the containers, the Docker will run. So what you need to do on that? And after the securing or hardening of course you need to patch the patching is something else, but you need to harden and patch. It should be both ways. And after that, you need to harden your container images, and you need to be able to audit, assess the vulnerabilities that is in the container instance, not only images. So when I say container images, let's say that for the guys that knows the virtualization technology, you create a golden machine and you clone it. So the basic idea for the containers, the terminology for images is being used like a golden image. So you create instance based on these images. So you need to look both ways, not only one. So to harden your container hosts, there are actually very good sites for hardening guidelines for the site called CIS Security. I was a security audit before, so auditor before. I was using the guidelines for the CIS. So there are lots of guidelines for you to secure, like CentOS, like Red Hat, like Windows or Cisco, whatever you have. So right now there are some guidelines or hardening guides to secure the Docker images, Docker technologies. So they call it benchmarks, by the way. So for the Dockers, and again, I strongly recommend you, if you are into security, I strongly recommend to enroll and subscribe on that project, so you will see a lot of hardening guides. Basically, with the hardening, you are making the hackers, you're creating a challenge for the hackers. Even with the configuration, you can actually block or a vulnerability or an exploit with the configuration file, not fixing the vulnerability itself. So there are, when you go there, and you will find some different benchmarks, guidelines, that will tell you how to secure Docker images. So those are the versions for the Docker itself. So if you are using 1.6, there's another guideline. If you are using 1.13, there's another guideline. Things like that. There are actually 1, 2, 3, 4, 5. Anyway, 5 different versions. There are the guidelines for 4 different versions of the Docker. But they're mostly the same, but the new versions bringing some new technologies. So you need to audit or secure or change some configuration file. So they add some new instances. So you can, actually it's a community-based project that you can enroll, and you can give some suggestions. Let's say, I think that changing that parameter from, let's say, 1 to 0 will actually give more secure environment for Docker. And it will be discussed, and it will be in the next versions. So I strongly, as a security aware people, strongly see what's going on at that project. So to harden your images, we at least start with using the default, the official images from the Docker. So you download some images because you need to base, you don't do everything from scratch with the Docker. You basically base your environment from an operating system, or from, not operating system, but operating system images of Docker images. So in the Docker file, that's the configuration file, you say, hey, I'm basing my new Docker images on CentOS. You basically say from, and you give the Docker image of CentOS or Ubuntu or whatever it is. And they are small, and they already provided by the operating system vendors. So when you use it, always use the official ones, so you don't get surprises. And you can add your script, the hardening script that is provided in CIA security guidelines. You can copy some commands and put it your own script. And as a last step, you can, in the Docker file, again, the Docker file is a file that creates Docker images. So you can create Docker images let's say that's a source code of how you create Docker images and the instance after that. So you say you can say as a last step, hey, harden CS run harden CS benchmark CentOS 7 sh. It's a shell script. So it will secure harden not your host operating system that will run Docker images, but also your Docker images. So you need to tweak some files in the Docker image itself and things like that. But the tweaking is it's not enough. Hardening the image itself is not enough because there will be always some exploits or vulnerabilities that you cannot fix or overcome by only securing or changing some configuration files. So you have to make sure that you run the latest versions of the Docker images that is containing latest packages in that image. So of course, and you need to audit, in your container environment. So far, what I have told you is that first secure the container host, then harden your container host, like what kind of patch should be applied, what kind of tweaking the configuration file should be applied on the host, and then what we have told that we need to secure the image itself, and then as a last step we need to assess or audit our images and instances as well. So, and yes, so I don't know, let me see. Yeah, I have time a little bit. So with Rapid7 software, actually, you can do all of them. You can check for the vulnerabilities for the operating systems, the host, Docker host. You can harden or assess your images. You can find the patch levels. So if there's a patch or a vulnerability in the Docker image or the operating system, the host, you can do both. And we have a product for that called Rapid7 Inside VM. Again, this one will help you to check the hardening steps. It will check some configuration files with our policies, and also find the vulnerabilities on the versions that you have already installed in host operating system and also Docker image. And also, that part is only not enough because the security is composed of the operating system, image, Docker image, whatever, and also the application. So the application should be secure too. So you need to secure your web applications. I say application, I'm trying to say the web application. So you need to secure the web application. So again, for that, we have another software called Inside AppSec or AppSpider that actually it's a web application like OWASP tools. We are implementing the best practices of the OWASP top 10. And of course, we have about 94 different attack vectors that are applied against your applications. So again, that tool can help you. So the tools, actually, the software that Rapid7 has is that's containing that dashboard that we call it Inside VM dashboard, or it's been called Live dashboard. and you actually have a special dashboard for the containers itself. So with that container, you will see in your environment what kind of host you have, what kind of assets containing the containers, what kind of images we have, and what kind of vulnerabilities each images have. And also, it's a live dashboard, meaning that with every scan, it's automatically updated, so you can utilize it. So it's also, you can add a dashboard. It's composed of some cards. You can add or remove some nice images, I would say. We call it cards. So you can add or remove additional cards to create your own dashboard or tweak it for your own needs. So and actually, if the dashboard is not enough and if you want to drill down something else, the Rapid7 provides you some special SQL-like query to query your own Docker or container environment. Like you can say assets contains containers, or asset containing containers that is already started, things like that. There are lots of SQL-like queries that you can use. Those are the most common ones for the containers. And with that, you can drill down whatever you want in this software. And also, as you can see, you will see, the containers are different from the basic operating system. Containers are based on layers. So every command that is being executed while creating your Docker image is actually creating a layer. So let's say that you have installed in your Docker file, you said, hey, install Nginx. Okay, another layer. And while there, let's update the operating system, like yum -y upgrade, another layer. So you add a user, another layer. All of them is a layer. So the Docker is based on the layered operating system, that I would say, the image. So we need to, we can see the layers that each layer can have different vulnerabilities. So the idea is to have no vulnerability in my latest layer, so it's up to date. It is containing the latest patch of the operating system of that container image. And the most important thing is that the Rapid7 integrates itself with different image repositories, the most trusted ones. So the Rapid7 constantly evaluates those images to give you the vulnerability that they have. So it can connect to different, Docker Hub or store with its new name, Docker Store. We can connect to Amazon, it can connect to other things. So with that, we will see the environment, what kind of vulnerabilities you have. So you can, as you can see, even if you have your own Docker repository, you can connect. And you can send those images to be reassessed. And of course, as a last step, as I told you, then you need to not only secure or harden or patch or assess the operating system, host, Docker image, but also the application itself. So the Insight AppSec tool is a web application scanning tool that is containing a lot of different vulnerability vectors or attack vectors like XSS, stored procedures, SQL injections, whatever. So you can find the vulnerabilities or try to find the vulnerabilities in your application code, not only the other things. Okay, so I don't know how many minutes I have. Okay, so basically I will get 2 more minutes to show you the software. Basically they are the screenshots that I already shown to you. So I have an environment here that's called Insight VM, our vulnerability, the Rapid7's vulnerability management solution that will show you the vulnerabilities for hosts, the operating systems, and Docker images, things like that. So in my environment, I have a site called Secops Europe, and I have only one asset. So this asset is actually here. It's called, no, it's an IP address and a host name, and this operating system has that kind of vulnerabilities, so 48. And there are 4 Metasploit modules that you can use to exploit those vulnerabilities. And yes, and when I click on that asset or host, there's a special tab, aside from the other vulnerabilities that the operating system have. There's a special tab for containers, as you can see, the containers that is running on that. And also, I told you about CIS security, there's a special tab for the policies. So basically, you are assessing your operating system, host operating system, the Docker operating system, based on some standards like CIS ones that I mentioned to you. So how compliant you are. So when you click on that, so you will see on which bulletins, which matters are you are failing. So let me click on that. And actually, yeah. So restrict network traffic between containers. Those are actually the matters, the bulletins that is found in CIS security. So CIS security's Docker, CIS security's Docker benchmark is actually composed of some security hardening guides, and we get it, and we can assess your operating system based on that, the host operating system. And after that, I will show you the dashboard for the containers itself. So I will show you our container dashboard that is, containing one asset with deployed containers, that one operating system, and right now it contains one image. Yeah, this is the image. So when I click on that image, I see some layers. So as you can see, on the last layer, we don't have any vulnerability. But on the previous layers, we have some vulnerabilities. Actually, since the Docker is a layered image, or let's say operating system or whatever, we care about the latest image, latest layer. But it would be nice to see the vulnerabilities for previous layers, for previous versions. So when I click on that, actually I will see the packages on that image, on that layer, not on an image, but on that layer. I will see all layers here on that this image. I will see the vulnerabilities. I will see the history of that Docker image. So when I say history, I'm talking about the layers. Each executed commands. Let's say that this is Nginx, basically a web server, the image, Docker image. Then the Docker is updating, the owner of that images, probably the Nginx software group, is updating those images or adding some new versions of the Nginx and also updating the base operating system on that image. As you can see, we provide everything to you. Yeah. So that is what I want to show you. So if you have any questions, okay. Right now, none. Anyway, I think I'm done with my minutes. Thank you. Thank you for your listening.